Can you hear me now? Okay. Hello, thank you very much. So, have you or your employees ever needed important instruction while performing an important maintenance task? Or perhaps, have you ever wondered what a piece of art meaning was while staring at a statue or whatever? Well, I did for many reasons, not just because of my job, as you will see, but because we, as human beings, interact with reality always, continuously. And asking questions about reality is what we human beings do. So today, I would like to talk about how augmented reality can help to make our lives better from this point of view. And to this regard, I will also talk about specifically about object tracking, so the most advanced achievement from this point of view. And finally, I will talk about some important use cases that make that help us to describe how augmented reality effectively can help us. So, depending on your background, your job, or your interests, you may know or not what augmented reality is. So basically, I would like, first of all, to define augmented reality, because if you look for augmented reality on the web, this is what you will look for, you will find. And actually, this definition is not 100% complete. Indeed, it is just 33% complete, if you want. But a more complete definition of augmented reality has been given by Ronald Azuma in a survey on augmented reality, and basically it says almost the same thing as the previous definition, but a little lines later in his survey, he adds that an augmented reality system actually has three major components. The first one requirements that augmented reality systems must combine the real and the virtual, and this is the same thing that we have seen so far. But also, it must be interacting in real time. This meaning that all the action for the end user must happen in real time, not like it happens, for example, with visual effects like we see in movies. And most importantly, another characteristic of the augmented reality system is that it must be registered in 3D. This meaning that an object that you display using a smartphone or a smart glass must be strictly attached to the reality. So if you move, the object stays in place and doesn't float or somewhere, or it's just fixed on your point of view. For the sake of completeness, we also can talk about a mixed reality, because lately this is something that is coming out more frequently. And the mixed reality actually is a wider concept than augmented reality. If you look at this scheme, you see that augmented reality is just a part of mixed reality. Mixed reality actually entails everything that comes from the reality and overall, to virtual environments, so virtual reality, but does not include both virtual reality and the real world. And so basically, augmented reality is just a specific case of mixed reality. But look at this picture. We are all used with this kind of blockbusters and movies and visual effects. This may look like augmented reality because we see the T-Rex exactly there, and we have we think that Tyrannosaurus Rex is there. But actually, what is missing? Why this is not augmented reality? This is not augmented reality because it's not interactive. It's missing one important thing: interactivity in real time. And specifically, to create this kind of image, you will need very, very power computers, specifically render farms. And so just to create one single image for this kind of visual effects, you will need a lot of time. Whereas, when talking about augmented reality, usually you have to create real-time computer graphics, and you have to do it eventually on smartphones or eventually on other devices that have very little computational powers, like smart glasses. So the requirements are very different, especially if you think that what happens with the augmented reality is that the hardware and software must, in a way, understand the reality. And also, it must be done continuously for 30 or 60 times for each image. Fortunately enough, the hardware evolution helped us a lot from this point of view, because starting from 5 or 4 years ago, the performances of CPUs also on mobile devices improved a lot. So we managed to have very interesting things also on mobile devices. Just sum up the differences among these kind of technologies. So we say that augmented reality has these characteristics, and what makes it different from mixed reality system is the fact that in augmented reality system are registered in 3D, so the objects are exactly there, whereas mixed reality system are more relaxed from this point of view. Whereas regarding mixed visual effects system, what is missing is the interactivity in real time. As I told you, what is really, what happens behind the scene for augmented reality system is an understanding of the reality, and this must happen continuously. And this is a very, very strong requirement for augmented reality system. And one may think that basically the understanding of reality could be just some algorithm that look an image and try to find out what's happening. But actually, in order to achieve real-time performances, we must rely on at least two kind of processes. First, recognition, understanding where an object is, and eventually also understand how the camera is positioned with respect to that object. But to have real-time performances, we have also an important task that is usually called tracking. So basically, we try to find some important features in a smart way and not on all the image, for instance. And this allows us to run at 30, 60 frames per second, for instance. Basically, to do this kind of things, so to understand the reality, we rely on sensors. Then either common sensors or camera, anyway, are also sensors by themselves. And using camera-based methods, you can track and recognize markers, as we will see, or images like posters, blueprints, or the environment itself, or objects. And this is what we will focus in a while. But you also can rely on sensors. For instance, if you want to track the user position on Earth, or you can use, oh, sorry, I just skipped away. Here it is, sorry. I was saying locations or the inertial measure units, so basically the orientation of the device in space, or also mechanical sensors that allows you to have very accurate positioning of a device, or electromagnetic and acoustical methods. This is an example, for instance, of a marker-based tracking. And the problem with this approach is that they are, actually, one of the advantages is that they're very, very fast. Indeed, it's one of the first techniques that was used in the early days of augmented reality. Also, you can understand that there is something, and so they are very noticeable, and you can understand that something will happen if you look at this kind of things. Sorry, they have some problems. For instance, they are very ugly, and if you want to make a marketing campaign, for instance, for a good-looking object like a car or something else, it's not very good to use these kind of objects. And another problem is that they're very sensitive to lighting changes. So if they have shadows on top of them, they will stop working. Or if you cover an edge of the black square, it won't work anymore. But Another problem is also that they are noticeable because they're very eye tracking, and so it doesn't make sense to use them everywhere. Another approach that is usually better is based on images. And in this way, you can track and recognize features on generic images, so posters, blueprints, and the likes. So they're usually nice to use, and the user won't complain about it. They're also fast, so they can be used on mobile devices as well. And they're less sensitive to light changes with respect to the previous technology. And they also have quite tolerant behavior with respect to occlusion, so you can cover the page, for instance, of a newspaper. And you don't notice that there is something special with this kind of images. So this is actually also a problem, because you have to tell the user that there must be something happening on that page, so you have to use also stickers to trigger the augmented reality, actually. And also another important kind of method to understand reality is based on what is called simultaneous location and mapping. It's SLAM approach, actually. And it allows you to scan the environment you are in and to create a map of the environment. Actually, this kind of approach is quite fast, so it's usable also on mobile devices. And it handles occlusion, so you can also move in the environment and not affecting tracking too much. You don't know that something is in that environment, so there must be some mechanism to tell the user that something happened there, but this is not really a problem, actually. And one problem is that you have to make some specific movements to start tracking and recognizing the environment. And it's called usually a SLAM dance, exactly. And if lighting change in the environment, the map that you have created may not work anymore. Also, a problem with this approach is that if you use it just as is, you won't have any information about the size of the environment that you are scanning, so you have to add other information. And you cannot recognize a specific place or an object in this way. It's very difficult. Another tracking method that we have mentioned is location-based tracking, but basically this method is it's still very fast. It relies on the GPS and the IMU unit on your devices, so the compass and gyros and so on. And also, it does not have any problem with light changes, because it relies not on vision, computer vision, but just on sensor installed on your device. And it works very well with objects in the distance, not objects really near to you, very close to you, because of the errors of sensors. So you know that you use GPS, the position can change, and this is not very accurate. You could have 5 meters errors, so it doesn't work with close distances, but just long distances. But it drains your battery, and actually, this should be in the other list, you can manage occlusion because you are not using computer vision. So you can also pass through in front of an object, and you will see the object in augmented reality as well. Usually, for this kind of things, they are using with balloons like this to highlight some spots, but this method doesn't work very well if you want to, for instance, display some object in front of that church and have this object stick to the church itself, because you see that sometimes the content moves and floats in the air. Yeah, this jittering problem. Also, the sensors are usually very noise dependent, so if you have electromagnetic fields nearby, the GPS won't work very well, or the compass and things like this. One of the most important achievements in computer vision tracking is object-based tracking, and this is what I'm going to describe better. The good thing about this approach is that it works in real-world scenarios. So this makes this method employable in real-world scenarios. somehow it does not, it is not affected a lot by lighting changes, as we will see, and it can handle also occlusion of the object itself. The problem is that you don't know if an object can be recognized or not. You have to add some information to it, or you must know it in advance. And also, lighting changes, it's also a problem because depending on the technique, it could be affected, the tracking mechanism could be affected by lighting changes as well. And some methods, especially the most recent one, are quite slow, not really performant, but with advances in hardware and techniques, these problems are going to disappear in a few months, maybe. And so with the latest improvement and the latest devices, these are not really the problems anymore. So one question is how we can make AR. We have seen what AR is and some of the methods that can be used for augmented reality, but you have several kinds of possibilities to create augmented reality experience. You can rely on authoring tools, basically can be in form of plugins for content creation software, or platforms, general purpose platform or vertical platforms for the industry, for instance, or for Catra Agent. You can choose many for them. And these kind of tools are mostly designed for content creators, so not programmers and the likes. Or if you are a software developer, you can rely on software development kits. In this case, you need programming skills, eventually computer vision skills, and everything that is related to software development in general. Or you can use a mix of the above approaches. For instance, you can rely on softwares like Unity 3D that can be used either by content creators or by programmers. And so this is a more hybrid approach if you want. Or finally, you can just ask someone else to create the augmented experience for you. So, for instance, you have an industry, a factory, and you want someone to create an application for maintenance, and you can just ask someone else to do it. And this is just something that can cost you some money. So, for instance, this is an example of a plug-in approach. Basically, in this case, we are using a 3ds Max, and we have a plugin for 3ds Max. 3ds Max is a content creation software for 3D of any kind. So it's quite easy because you load or create your 3D model. And this is a classic view of 3ds Max. And then you have installed the plugin, and with just one click, you can see the same 3D model in augmented reality, like we see now. And this is very easy from the user point of view because you just use tools you are used to, and you are not to learn anything else. And this works just in real time, as we have seen right now. Or if you want to, you are a developer, you can use SDK, I would say, and this is just a matter of writing code, but it makes sense depending on your business. And the other approach I mentioned was a hybrid approach where, for instance, if you're using Unity, you import the tracking core and a package inside Unity. You import the trackable data that represent the object that you want to track, and you set up your scene, the content, and then finally you configure the player settings and deploy the application or mobile devices or whatever. And these are typical screenshot of one Unity plugin. You see all the steps. You have the targets that you want to track, and you can add the content on top of that. Make some configuration steps, and that's it. Nothing else. So now I want to go to the core of the subject, and we have talked about the definition of augmented reality, how you can make augmented reality. And among all the methods that we have talked about, there are some that still make sense. For instance, the image-based tracking methods, it still makes sense. Sometimes the marker-based method also. But in some scenarios, for instance, in the industry, if you want to provide instruction for machineries in a factory, you could have thousands of machines. Or if you think about a museum, maybe the museum itself won't allow to add markers or images or stickers on top of a piece of art, of course. Object tracking is very useful in this kind of scenarios, as we'll see. Basically, there are two main approaches to object tracking, feature maps or feature-based approach, and model-based or edge-based approach. On the left, you see a typical feature maps approach where features from the object surfaces are extracted and are used to represent the object itself, while on the other side you see a typical model-based approach. And basically it works by finding edges, important edges of the object. Simply stated, with features-based approach, you search the surface of the object you want to recognize and track, but using the edge-based approach, you recognize shapes, more or less. This is the feature map approach in action. Here you will see the features that were extracted from this car, and they are tracked in real time. Also, using this approach that is quite fast, you can not only recognize one object per time, but you can also eventually use more trackables and more objects at the same time. For instance, with the same application here, we were tracking both the exterior of the car, but also the dashboard, like you see in this case. Previously, we were just looking at the features. Now we are looking at a real application where you can tap each spot and get information about the functionality that is highlighted. Here you see the object tracking methods, that is the edge-based tracking. In this case, you have, for instance, a wireframe of the car, and you have to align your camera and the wireframe to the real object. And when the alignment is done, you can start moving and track the object. So in order to compare these methods, let's consider the phases that one has to pass through in order to create augmented reality experiences in general. The phases are this one, and specifically the trackable authoring phase is where you define the object that you want to track, and also where you define the coordinate system where all the contents will be placed with respect to the tracked object. The content ordering phase is where you add the actual content on top of the tracked object. And this phase is overall usually done by a team of people that could be developers or content creators, something that is using an authoring platform. And together are usually called just authoring for simplicity. The final phase, the experience execution phase, is where you deploy your application and the trackable data to mobile devices, and another person different from the one that created the application experience the augmented reality content. And this may be different, but in the initial stages of the development, it could be the same person that were just trying to tune the tracking engine and trackable data. So let's go through each phase. Talking about the trackable authoring phase, let's focus first on feature maps approach. Here, you usually take several pictures from many angles of the object that you want to recognize and track. And from those pictures, you create, using specific softwares or platforms, a point cloud of that object. So a 3D representation of the features of that object. And also, as you can see on the blue squares, the method allows you to create to reconstruct the position of each photographs that you took to create that point cloud. And this is important because during the execution of the experience, the user somehow must be near those positions in order to start tracking the object. Whereas the model-based approach requires you to provide a CAD model of the object that you may have or may not, and from that CAD model, you highlight boundaries or the shape that you want to actually recognize, and also provide the right angle that will be the starting position for tracking. So basically, when a user will use your augmented reality experience, he should try to align this shape to the real object, and then he can move around. But with the feature maps approach, actually, you must do some steps, specifically using the pictures that you have taken of the object and a reference 3D model. You must make some correspondences from 3D points and 2D points in order to choose the same coordinate system of the 3D model. And this, as we will see next, allows you to place the content correctly with respect to the 3D model, and then when you will use the experience, you will see the content exactly in that position, but with respect to the real object. Whereas the model-based method actually doesn't require any other step. Talk about the content authoring, you will basically use content creation software or any platform that allows you to create the reference model that you have used, either the CAD model or the point cloud that you have reconstructed. And using your content creation software, you just place the content all around this reference model. In this way, when the augmented reality experience will be played on mobile devices, you will see that content exactly in the position that you have specified using these tools. You can also add not only 3D models, but also movies or create interaction among the objects and the likes. This is actually a representation that comes from the reconstruction of model car and using the feature map approach. And this model is very noisy because it was reconstructed using the point cloud, and the object itself is very reflective, so it's quite bad, but just for demonstration purposes. Whereas for the CAD model base, you just have an accurate CAD model, so everything looks much better from this point of view. So let's compare a little bit the both methods. First, there's another step. The third phase is when the user must use your augmented reality experience. Let's pretend that he needs to track this car. And using the feature map approach, the user needs to put his device in a way that resembles one of the images that were used to create the point cloud and the tracking data itself. So if the user managed to be close to any of those point of views, he will manage to start tracking the car. Otherwise, he will not. On the other hand, for the model-based tracking method, what happens is that the user must align the 3D shapes that has been used during the previous phases to start tracking. That's how the initialization phase works. And I want to compare these methods under some respects. For instance, the steps used required to create the trackable data for both methods are very different. For a model-based method, you just need one step. Basically, you just load the CAD model and choose the point of view. For the feature map methods, actually, you have to do a lot of work. Take pictures, create the point cloud, align the model, so it requires a lot of work, actually. But the starting points for tracking using the feature map methods are many more. So you actually could start tracking an object all around the object itself, while using the model-based approach, you just have one point of view to start tracking. And initialization time, it's actually quite high, usually for the feature map approach, because it's true that you can start tracking from many points of view, but this kind of search of the right position can require some time, whereas the model-based approach, once you know the position that you have to have, it's very quick to start. Also, other important factors that can affect the user experience and the quality of a method are the one that we are going to look now. For instance, the feature maps method is affected quite a lot from lighting changes, because it depends on how you took pictures of the object. So if light is different from those pictures, you may have problems, whereas the model-based approach is not really affected from this point of view, because it just recognizes the shapes as long as there is a minimum light in the ambient, in the environment. The appearance, this meaning the appearance of the surface, it could be textured or not, it could be dirty or worn, and of course the feature map methods is affected a lot from this point of view, because it really depends on the appearance of the surface and not the boundaries as the model-based approach. The environment that is surrounding the object for the feature map approach can be actually removed from pictures, so you can say that it is not affecting it very much. And using the model-based approach, since we are focusing only on the boundaries of the object, again, doesn't affect the tracking a lot from this point of view. Reflection and opacity of the object can be a really problem for feature maps approach, because if you move, you will see the reflection on the surface of the object moving around, so tracking will be very bad. Whereas this doesn't happen with the model-based approach, because reflection are not present on the boundaries, on edges. And finally, sorry, not finally, there's another one, usability. This meaning that how easy to use these methods. Talking about developers and content creators' point of view, we have seen that creating trackable data for feature maps requires a lot of steps, whereas for model-based tracking requires just one or a couple of steps, so it's much more easier. But talking about a user and point of view, feature maps methods usually it's easier, because you can start recognizing and tracking an object from many different points of view. Whereas for the model-based methods, you have just one point of view to start from. This is the reason for these colors and the signs. And finally, the generalization parameters is related to the fact that you can recognize not only one specific object, but many objects that are identical to that one. For instance, you can think about a component or machinery and so on. And problem is that model-based approach can be, it's very good from this point of view, because it does not take in consideration, for instance, all the dirt that can be on the surface, so every object that has the same shape works great with that object. Whereas the feature map approach, if you have taken pictures of an object, maybe on an identical object, but with different scratches and so on, it will not work. I want to go a little fast on this, it doesn't add many things. Basically, you can mix the initialization and the tracking phases, but I want to talk a little bit about some use cases I've been working on. And these use cases have been enabled in real-world settings thanks mainly to the efficiency of the latest computer object tracking methods, also the availability of vertical platform for creating the augmented reality experience either in the industrial sectors or in cultural heritage, for instance, and also thanks to the availability of mobile and wearable devices. The first one is a project that we have been doing lately with Huawei. Actually, since more or less 2 years, we are doing some experimentation with them. And with this company that does not always create mobile devices, but also inverters and solar photovoltaic systems, we have created a system for maintenance and training to carry out important tasks on this kind of equipment. So here you will see instruction about steps that you can do on the real object itself. Then I go fast on this. Okay, this is another use case, I want to skip it. This is another company that creates a mechanical component. And again, here we just highlighted some information on machinery for visitors of the factory themselves. And also another nice use case is related to ABB. And again, we provided instruction and augmented reality for maintenance of specific equipment. But I just want to go ahead because the time is over. Okay, just this. Sorry about this, I want to skip it. Okay, this is a nice use case in the cultural heritage field. Here in Rome, we use augmented reality to provide instruction like this to users. So basically, you have a Samsung Gear device, use it with the pass-through technology, so not use it for VR, but for augmented reality. And you can see how the Arapacis monument was in the original times. That's it. And if you go in Rome, it is available in the evening if you want. Okay, I think this is the last one in the automotive industry. One nice thing about this use case that not only we were using mobile devices like tablets and smartphone, but also the Epson Moverio smart glasses. And we created an interface with the onboarding system, so we get real-time information about the engine and consumption and the likes, and we see them on the smart glasses display. So that's it. I hope that I've shed some light on object tracking. Now they can help in real-world scenarios. If you have any question, please, you're welcome.
Thank you, Alessandro.
Thanks.